We are going to graph tangent. Pardon me while I just flip the screens around. We're going to start with graphing tangent, and we're going to talk about it first. We know that tangent is sine divided by cosine. So we know that tangent is sine of x divided by cosine of x, and that equals tangent of x. So I want to point out a couple quick things here. First of all, from before, we know that if we are dividing by 0, if the cosine x equals 0, then we're going to have a vertical asymptote. So I know that this blue function here is going to determine all my vertical asymptotes. So I'm going to start by putting in my vertical asymptotes. And instead of doing dots, I'm just going to do vertical lines because it's slightly easier on me. I'm only going to do a few of them. So those points should be pretty easy. I also know that if I have a 0 in my numerator, that 0 divided by any number is 0. So if I think about where my sine function equals 0, like right there, 0 divided by 1 is just 0. So this dot that I put on my graph is on my graph. And this one here is also on the graph that I'm going to do. And those are the only two sections that I've mapped out. It would obviously continue forever. And then I know that when the two values are equal, right, if the sine equals the cosine, like at root 2 over 2, or I'm sorry, at pi over 4, then their value is 1. So right here, they're equal, sine equals cosine, so their value is 1, which is right there. And similarly, over here, I have two negatives divided by each other. Their value is also going to be 1. And over here, I'm going to have a value of 1. So what we also need to realize is that there is a point right here where these two values are equal and opposite. And at that point, it's actually going to have a value of -1. So I'm going to put a dot down there for -1. And another dot down, where am I, down here for, well, this one's 1, I missed this one, so 1 is right about there, and then I'm going to have a -1 somewhere over here. And it should be symmetric, Sweet, so this might look a little weird, but what happens is that this function follows my vertical asymptotes really close, and it starts hooking over here, and it hooks that way, and then it hooks here, and then boop, it goes up. If this looks like a cubic, that's a great analogy to look at it with, right? And so same thing here. We're going to go like this, like that, and up. So this is our tangent function. I want to point out a couple quick things. Notice the domain of our tangent function is basically everywhere except where cosine is 0. And then our range is all real numbers. It's all real numbers, so it goes on forever. But the other important thing to note is the period of this function. The period isn't 2 pi like most functions are. The period is just pi. So this function repeats itself twice in one go. And I'm going to do one more thing. So hopefully that this makes some sense. I want to point out our unit circle. When we are talking about tangent, we're talking about sine divided by cosine. So the height divided by the width. That should feel like slope. And if you notice, if we think about starting here and we look at the slope of my hand, it's 0, which is right there. And then as we go through, at pi over 4, we get a slope of 1, which is right there. So we have all these small slopes, and then we get a slope of 1. And then we keep going, and you guys should know that a vertical slope is positive infinity, right? Or it doesn't exist, so that's why it's a vertical asymptote, and it kind of just goes up. And we could do the same thing going in the reverse direction, where you come at 0, 0, and then at -1, and then negative really, really steep. So I hope that helps. And I'm going to try to close out of this.